Well, hello, Algebraic Reasoning. Today we're going to review for the final. So let's have at it. So the first question, y to the fifth times y to the third. So the first thing I want you to realize, if you don't see immediately what the answer is, what does y to the fifth mean? Y to the fifth means y times y times y times y times y. In other words, you have 5 of them, right? And then y to the third means you have 1, 2, 3 of these. So if you have 5 of these and 3 of these, how many do you have total? Well, 5 plus 3 is what? 5 plus 3 is 8. And so the answer is y to the 8th. Okay, so let's take a look at the next question. So the next question is 6 raised to the 0 power is equivalent to. We've already mentioned before that anything raised to the 0 power is 1, or except for 0. And the easy way to show this is 6 over 6 equals 1, but we also know that 6 over 6 is the same thing as 6 to the 1 divided by 6 to the 1. And the rule is that when you divide, you subtract the exponents, which gives me 6 to the 0. So if 6 over 6 is 1, but it's also 6 to the 0, these two have to be equivalent, and that means that the answer is 1. Okay. Also, as a little aside, if you forget how to deal with any sort of problem in regard to exponents, they're just extensions of PEMDAS. So division and subtraction are correlated. So notice that when we're dividing, we ended up subtracting. That's not a coincidence. These are group subtraction is division, and that's why this property still holds. And this will play a role later on when we play with logs. So keep that in your bag of tricks. All right, next one. M to the fourth squared. So again, if we refer back to here, we said multiplication and exponents are related. So what do you think we do here? That's right. We're going to end up multiplying. So 4 times 2, m to the 8th. All right, moving right along. Next one. Here we have a negative exponent, and negative exponents is a fancy way of saying reciprocal. Okay. So that means that I'm left with 4 over 3 squared, and keep in mind that that just means 4 over 3 times 4 over 3, right? When you square something, it just means you're multiplying it by itself. So 4 times 4 is 16, 3 times 3 is 9, 16 over 9 is my final answer. Let's keep this going. All right. How do we express 50,700 as in scientific notation? Notice in scientific notation, this number here that is in front is always between 1 and 9. I'm sorry, I should really say it's between 1 and 10, including 1 but excluding 10. So anything that 1 or more up to 10 but not including 10. Okay. So if I have, this is very simple to do. Just take your decimal place and count how many times you move the decimal place. So 1, 2, 3, 4. I move it 4 slots. So that means it's going to be times 10 to the 4th. Okay. Notice that when it's negative, the decimal would be moving to the left. Okay. Negative meaning the number is smaller. And that should make sense because we referred to what negative means in the previous examples, the reciprocal, right? So that refers to flipping it. So if you have 10 to the negative 4, that is the same thing as 1 over 10 to the 4th, which is 1 over a very big number. When you have a very big number, then that 1 over a very big number means you have a very small number, right? So that would make sense. So when it's a negative exponent, the numbers are getting is a very small number, i.e. 0.0000 something. Okay. All right, moving on. So here we have a great exercise in not only distribution, but also playing with exponents. So negative 7 times negative 12 is the same thing as 7 times 10 plus 7 times 2. So that's 14 plus 70, which is 84. Negative times a negative is a positive. The rule that we've already referred to is that when you multiply, you add the exponents, and if that is an issue for you, you see me keep scrolling back to previous problems to kind of reinforce what we've talked about before, which is that addition and multiplication are related. So we're going to add them, keep it going, negative 7, I guess I'll do this a different color, negative 7x to the 7th times negative 3x squared is going to give me positive negative times is again positive. 7 times 3 is 21. X to the 7 times x squared is x to the 9th. And we finish this up with the last one, which is negative 7x to the 7th times 7, which is negative 49x to the 7th. Okay. All right. So what do we see here? Well, we can see that if you're going to need an x to the 7th in the back. So that is gone. That is gone. That is gone. This is the only one that makes sense, and this one matches up exactly with my answer choice. So I want to stress here that great test-taking strategy, particularly on things like finals, is don't just choose the right answer. Make sure the other ones are incorrect, okay? By doing that, you really help yourself in avoiding making silly mistakes and choosing the wrong answer. Okay, next problem. So we've seen an example like this before. The big thing is to realize that squared means you're multiplying by itself or you're distributing the 2 into every number, including the letters, right? So the place that most students make their mistake is right here. They forget to put it with the number. So you're squaring everything. Also realize that 4, how did I get 8? I did 4 times 2. How did I get 6? 3 times 2. And how did I get 8 in the bottom for the exponent? I did 4 times 2. Okay, we look to combine like terms. That's not the case, but we do have 2 squared, which is 4. So the final answer is 4 p to the 8th v to the 6 over s to the 8th. I'm going to look at the bottom for s to the 8th. That means that this and this goes away. 2 is not the first number. P8 v6. That's the correct answer. Okay. Again, notice I eliminated answer choices, not just choosing what I thought was correct, but seeing that the other ones are incorrect as well. Great idea to keep in mind when you're working through problems so you don't make silly mistakes. All right, next one, factoring. What is factoring? Factoring is reverse distribution. So what do I mean by that? Instead of multiplying values together like we do in distribution, we're going to divide out. So we're going to divide out what they have in common. So I see negative 10, negative 40. I can see that they're both divisible by negative 10. And then I can also see m squared, m to the 4th means I can take out the most amount of m's, which is m squared. So I'm dividing through by negative 10 m squared. That means that's going to go on the outside. On the inside is what happens when I divide them. So when you divide through, it's 1. When you divide through on the second part, it's going to be 4. M to the 4th divided by m squared is m squared. We watch the signs, make sure the signs are okay, and that seems to me to be the answer choice A. Again, you could distribute back in to double check, and if I do that, it does seem like I did that correct. So there you go. Nice. Next question. Here we're illustrating how to add vertically, and this is just combining like terms. So negative 7y squared and 11y to the 5th. Notice that when we combine like terms, we add things that are alike, but we don't play with the exponents. So in other words, you're not adding the exponents. These are little things to take note of as you study to make sure you don't make silly mistakes. I like to think of this as you have 4y to the 5th plus 7y to the 5th. So if I have 4y to the 5th, right, and then I add an additional 7, 1, 2, 3, 4, 5, 6, 7, how many y to the 5ths do I have total? Well, I got to have 11, right? Same thing as saying 11 y to the 5th. And that's why I see that I'm not multiplying the exponents. If you think logically about these situations, really they should be pluses in front of all of these. If you think logically about these situations, there is no need to memorize, and you're able to do this. If you start memorizing random facts without realizing where they're coming from, this becomes impossible to keep all in straight in your head. So make sure you get this straight. Keep the rules of addition versus multiplication separate. That's important. It's worth the time I spent talking about it. All right, next one. Okay, so the parentheses here are designed to distract you, but all we're doing is actually very similar to the last problem, just combining like terms. So I have 8y and I have 4y. Those are like terms. You got 12. What else is a like term? Well, hopefully you're saying -5 and -1. And when we put those together, you get -6. Notice -5 plus -1 is -6. That is my beautiful answer. Notice I did not do y squared, which is this answer choice. We just combined like terms and then we got it. Okay, nice. Next bit. All right, so more of the same. We're going to be eventually combining like terms, but we also want to start this one off by distributing. And one nice thing to always keep in mind is that if you have any doubts as to step 1, if you notice you can distribute, 9 times out of 10, that's a safe move. But once I've done that, notice I'm right back to the same situation. We're going to combine like terms. So I'm going to put 50 and -36 together. That's 14r. And then I'm going to turn to the -40 and the 35, and we're going to put those together. Notice that I am subtracting them and taking the sign of the bigger one, because the sign of the bigger one is negative. It's -5. Whereas in the previous, with the linear term, with the r, the -36 and the +50, those were different terms. So I subtracted, but I took the sign of the bigger one, which in this case was positive. Okay, so you've got to get your rules straight in your head. It's the time, guys. It's time once and for all that this stuff starts sticking in your head. So hopefully that's okay, and we're going to move on. Next up, okay, so this is just more of what we've done. We're going to multiply values that are alike. So you have m cubed times m squared. The values that are not alike, y to the 6, hang out by themselves. So what do we do when we multiply? We add the exponents. So it's going to be m to the 5th times y to the 6, and that's my answer. All right, let's keep it going. Next one. All right, so we got this 3 on the outside, but that just means, we've seen this before, you're just going to distribute to every term. Again, the common mistake is people don't take it to the last, to the number. That's where people make their mistake. Also want to stress that 5 cubed is not 15. A lot of people say it's 15. It is not. It's 125, because 5 to the 3rd is 15. I'm sorry, 5 times 5 times 5. 5 times 5 is 25. 25 times 5, 5 quarters, is 125. There you have it. All right. Okay, so again, now we're kind of putting all of these rules together. These are problems that are very typical of any sort of entrance exam, so you really do want to make sure you're cool with this. We're going to first distribute the -6 to everything, and then we'll do the same thing with the 3. So the rule is that you multiply. So -2 times -6 is +12. 4 times -6 is -24. On the bottom we have 4 times 3, which is 12. B to the -24. This is actually kind of cool, the fact that we have -24, -24 matching up. And I say that's cool because these will just divide out. And actually, these will divide out as well. So this problem actually ends up just becoming 1. Note, if you wanted to, you could have taken the negatives and you flipped them. So maybe some of you guys are thinking about flipping them and making them positive, and that would be legit. They are the same number, so it looks like I'm just rewriting it as positive. But you could take this -24 and put it on the bottom, and this -24 and put it on top. Remember, again, when you have a negative exponent, that just means it's the reciprocal. Reciprocal is just a fancy way of switching numerator and denominator. It's a fancy way of saying that. So I hope that makes sense, and let's keep going. All right, next up, we got some classification of terms. We see we have 3 terms. When we have 3 terms, that is called a trinomial. Terms are separated by plus, minus, and equal signs. Let me say it again. Terms are separated by plus, minus, and equal signs. Okay, so we have 3 of them. That's a trinomial. That means anything that has a binomial would be wrong. That's my only answer choice I can eliminate. The degree is the highest exponent, which is in this case 6. There you go. All right. Moving on. I think I actually just did this problem earlier, so there's your answer. Let's keep going. I think this is different. So we're going to add these. This is very similar to something we had before. The big thing is that when you're adding these is that you do not want to let the parentheses confuse you. If it's positive, you can just drop them all together and just combine like terms. So y to the fourths go together. So 9 and 5 is 14 y to the fourth. So that's going to leave me, it better be negative 3y cubed in the back. And we have, so let's see what happens. We got plus 6y cubed minus 9. 6 minus 9 is negative 3. Y cubed, perfect. There's my answer. All right, keep it going. Next up. All right, so we got 3 questions in one. This is just trying to reinforce what we've discussed previously. So what type of expression is negative 2b minus 11 plus 4b squared? Again, I said 3 terms. Terms are separated by plus, minus, and equal signs. So this is a trinomial. 3 terms. Which of these terms is a binomial? Binomials are separated by 2. Now, the first one you may be tempted to say is binomial, but we can actually add 4 and 17. They have to be different terms, so that's not going to be correct. 3 minus b squared looks pretty good. B to the negative fourth. So one thing, these are binomials are what we call a polynomial. Polynomials have positive exponents, and they have to be positive integers actually. And integers are plus. Essentially, they have to be numbers like 1, 2, 3, 4, 5. Okay, so because this is negative 4, that's a no-go. And this is a term, but this is what we call a monomial because it's one term. Notice there's not plus anything else. So the only one that makes sense is B. Last one, number 3, which of the following is classified as a monomial? So again, hopefully you're looking at the first one, you're saying that's no go because it's negative. N over M, again, is not going to work. Think of it, N over M is the same thing as saying N times M to the negative 1. And I just told you that exponents can't be negative. Square root of y, this is important to know, square root of something is the same thing as raising it to the 1/2 power, so that can't work. So the only thing that's going to work is negative x cubed. So notice, be very careful here, negative is okay in front, but it is not okay as an exponent. Let me say it again. Negatives are okay in front as what's called a coefficient, so you could have like a negative 2 or in this case negative 1, but it's not okay as an exponent if we're talking about polynomials, which a monomial is classified under. All right, so I hope that makes sense, and let's keep going. All right, so here we got a lot of negativity. We know negativity just means it switches its position, so I'm going to start off by doing that. I'm going to rewrite this as m to the 13th n over m to the 6th n cubed, and all I did was get rid of the negative exponents. This doesn't have to be your first move. It's my first move because I don't like dealing with negatives. We also know that the rule is that when we have the same base, we can subtract the exponents. So this is going to be m to the 7th. Notice here in the back we can do the same thing, but this one's a little trickier because we're doing 1 minus 3, which is n to the negative 2, which I don't see as an answer choice, but that's not going to leave me in this disarray. We know that when it's negative, it can also go to the bottom, and bottom meaning denominator, which happens to be answer choice C. All right, let's keep it going. Find the degree of each of the following polynomials and determine whether it is monomial, binomial, trinomial, or none of the above. All right, scenario we've seen before. You got 3. That's a try. The highest is 4. There we go. All right, so here we have a foiling situation. FOIL stands for first, outer, inner, last. Again, first, outer, inner, last. You can also do this the box method. So let me illustrate the box method. What should you do? You should do what makes you comfortable, is what you should do. So if you've traditionally done the box, keep it up, you'll be fine. So 3x times x is 3x squared. Negative 5 times x is negative 5x. Negative 10 times 3x is negative 30x. Negative 5 times negative 10 is positive 50. And once we write it as such, we're going to combine like terms. So we'll combine this. This is 3x squared. So the first one is just 3x squared. Then we have like terms. So that's negative 35x plus 50. And there's our answer. Okay. Again, most people tend, once they get comfortable, the most desired approach to this is foiling, which is first, outer, inner, last. So this is just saying you multiply by the first term. So you do 3x times x, which is 3x squared. Note the similarity. Then you do the outer, 3x times negative 10, which is negative 30x. Notice the similarity right there. And then you do inner, so you multiply these two, so that's going to be negative 5x, which is this term. And then you do the last, which is negative 5 times negative 10, which is positive 50. Okay, which we just did, and we see that it is the same thing as what I wrote here. Okay, I'm actually personally a fan of not even thinking about this as foiling. I just like to think of it as you got to multiply everything by everything. So notice I drew two arrows on top to say 3x is being multiplied by the two other terms in the other binomial, which is x and negative 10. And then negative 5 is multiplied by the two other terms, which is x and negative 10. So everything gets multiplied by everything, and as long as you do that in combined like terms, you'll be fine. I guess we should circle the answer here. So it's negative 35x. Yeah, there's two of them, and then it starts off with 3x squared. This is it. So notice I saw that and that go away because it's negative 35, and then the beginning is plus 3x squared, which means that goes out of the way. Again, illustrating that you don't just choose the right answer, but you eliminate the other ones so that you don't make silly mistakes. Now, let's look at this one. This one, what's very important, what's commonly made as the mistake is people distribute into both. You do not do that. What does it mean when you square something? When you square something, it means that you multiply it by itself. So we're going to FOIL this one. This one I'm actually going to FOIL out. If you're not comfortable with that, then you can use the box, or you can refer back to the last problem to see how to do that. And so you see me foiling it out. Just 8m times 8m is 64m squared. 8 times 7 is 56, so 56m. Notice the second one is 56m as well. And the last one is plus 49. So I have two 56s. So we can combine like terms here. That's going to give me 12, carry the 1. 10 plus 1 is 11. So we got a 112m, and everything else is the same. So we're going to look for that. We see that everything's plus, so anything with a minus sign is going to be actually wrong, which leaves me only with this as the answer. Also note that if you recall in class, I did actually talk about an easier way of doing this, which is x plus y squared is x squared plus 2xy plus y squared, and I'll leave it to the watcher to FOIL it out to see that it is that same thing. But what I'm here to stress is the fact that all this is saying is that the first term gets squared, hence 8m squared is 64m squared. The back term gets squared, all right? So y gets squared here, so the 7 is going to get squared and give me 49. 7 squared is 49. And we'll do this in light blue, the middle term is the product of x and y times 2. In other words, the product of 8m and 7, which is 56m, times 2, which is 112. Which, by the way, times 2 is the same thing as 56m plus 56m. So if you're comfortable with that, feel free to use that. That's, I think, is generally speaking, as you progress and you start working through algebra sections, if you decide to progress your education, you will find yourself naturally wanting to know that so that you don't spend a lot of time doing that. So keep that in mind too, especially if you find yourself wanting to do more math in the future. Okay. Let's look at the next one. So the next one is more foiling. I do want you to realize that because these are both positive here, the only answer choice that makes sense is answer choice C. But for educational purposes, I will FOIL. So 4x times 2x is 8x squared. 4x times 5 is 20x. 3 times 2x is 6x. And 3 times 5 is 15. If we combine like terms, 20 plus 6 is 26. That's the correct answer. All right, here now, this is what's interesting. Now we're going to be foiling, but in reverse. So we're going to factor this trinomial. So if you panic and you don't see how to factor, you can FOIL out each of your answer choices and see which one matches up. By the way, since this is both positive and positive, everything has to be positive. So the answer is either C or D. Kind of a nice thing to realize. How do we do this if we want to do it by hand, though? What you want to do is you want to draw two sets of parentheses, and you'll see me put W and W in front because what I want first to occur is that I got to figure out what times what is W squared. Well, clearly W and W times W is the only way to get to W squared. Then you go to the back term, and we look at 77, and I say, what times what is 77? Well, that's going to be 11 and 7. And this is the one time you're going to hear your teacher, maybe not the one time, but one of the times that you'll hear a teacher tell you, don't overthink it. Just slap something in there. Slap in 11 and 7. That's the first thing that pops in my mind. Anytime I see digits repeat, I instantly know that it's times 11. So like 88 is 8 times 11. 99 is 9 times 11, right? If the digits are repeating, it's going to be times 11. Now all I got to do is make sure if I add 11 and 7, do I get 18? Well, sure. That's definitely what happens. So that is the combination I want, and there's my answer. Okay. You can see that if you used 1 and 77, if you add these two together, you get 78, which is not 18. So that clearly is wrong. Okay? All right, let's keep going. All right, so here it says factor out the greatest common factor. Now, when you factor out a greatest common factor, this is a fancy way of saying you're going to see what you can divide everything through by. Now, the hardest part about doing this is playing with the numbers. And if you're looking for a systematic approach, take the biggest number, take the smallest number, which is 24. And ask yourself, can I divide everything through by 24? And 24 works with 48, but it doesn't work with 60. So that's not going to be the GCF. Okay. Now, if we're looking for the next one, there's a couple ways of doing this. One, we can just say, well, if 24 doesn't work, then we can list the factors of 24, which was 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. And so then you take the next biggest one, which is 12. Or, if you're like me and want to be lazy, i.e. efficient, you use the answer choices. So all these answer choices do have 12 in it, so you know it's got to be 12, right? And 12 does go into each of these. 60 divided by 12 is 5, so it does work with each of these. So 12 is going to work, which means A is wrong, so I've eliminated one of the answer choices. Then with the exponents, this is the part that's really easy. If you remember, the most you can take out, the most you can divide each of these by is the lowest exponent, right? Like, you can't take out a 7 out of x squared, but you can take a 2 out of x squared, right? So the most you can take out is the lowest. So between 7, 2, and 4, the lowest is 2. And the same game is applied to the y. So y is 9, 7 squared. Squared is the most you can take out. So we do that with everything. So we got x squared, y squared. So it's going to be x squared, y squared. So it's got to be answer choice D. But if you want to be thorough, then what we do is we put the 12x squared, y squared on the outside. Inside is the division of them. So 48 divided by 12 is 4. X to the 7 divided by x squared is x to the 5th. You should know that because of what would you do when we divide? We subtract the exponents. So 9 minus 2 in the next one is going to give me 7. that is matching up with the answer choice, so I know I'm on the right track. 24 divided by 12 is 2. X squared divided by x squared goes away. Y to the 7th and y to the squared is y to the 5th. 6 divided by 12 is 5. X to the 4th, x squared is x squared. And y squared cancels out. So does that match up to D? Yes, it does. Now, if you're me, the very last thing you'll do, because I know I have a propensity towards making silly mistakes, I will actually distribute one last time just to make sure it's correct. So that's going to be 48, x to the 7th, y to the 9th, which is what we had originally. The next set is going to be negative 24, x squared, y to the 7th, x squared, y to the 7th, that's correct. 12x squared, y squared, 12 times negative 5 is negative 60. X squared is x to the 4th, y squared, boom. That is correct. And there you have it. All right, let's keep going. Next up, we have some more distribution here. So this is nice because we'll just multiply the numbers and add the exponents. So we see that initially we're going to have p to the 8th. Notice that we are adding the p's, so you have 8 of them. So that means that, and 12, so that means the back 2 are going to be gone. The next one would be 21 p to the 7th, which means a is gone. But I don't just say, hey, okay, that's it, that's going to be the answer. No, you keep going. Plus 12 p to the 5th plus 3p to the 4th. All right, and that clearly matches up with B, so there's my answer. All right, next up. All right, got some transformations. So what do we know about transformations? Well, we know that when it's related to x, it is horizontal. Okay, so when it's related to x, it's horizontal. It doesn't matter what the function is. So this is going to be horizontal. Remember, horizontal is left and right. So that means anything talking about up is wrong. Anything talking about down is wrong. Okay. We also know that with x, it's the opposite. So the joke is that what do you learn from your x? You learn you want to do the opposite. So this means if it's plus, plus usually is to the right, which means that this one is going to be to the left. B is the answer. D is not. So when it's related to x, remember, it is the opposite. Okay. So with piggybacking off of that, we see x minus 1. So that means that's going to be x plus 1. So that should be to the right one. And that means that we're understanding because all these are to the right one. Now this has some more stuff going on here, right? So this also has times negative 1. Now the negative on the outside is a reflection over the x-axis. Okay, so it is reflected. Now the only one that's talking about reflected is D, so that's probably going to be the correct answer. And then with the term on the outside, this minus 5 on the outside, that shifts it up or down. And this is by your intuition. So minus 5 means it's shifting it down. Okay, so this one's going to be down, which matches with that. So the answer is D. That is also the only one that is true. Things talking about vertical stretch or vertical compression, this stuff is related to the number in front. So if A is greater than 1, it is a stretch, A being the number in front of the function. And if A is less than 1, between 0 and 1, it is a shrink. Okay. When we usually talk about this, the negative just means it's a reciprocal, so the same thing is effect. In other words, negative 8 would be a stretch, but negative 1/2 would be a shrink. Okay. One little note here, sometimes you'll see this written as absolute value of A is greater than 1. That is a stretch. Say we're not focusing on the signs. So the absolute value just means you're not focusing on the signs. And then we'll say when A is between 1 and 0, this is also called a proper fraction, meaning the denominator is greater than the numerator. This is a shrink. Now I know it's a little overkill, but that is important. That also tells us that these two have to be wrong. So I know for sure these two are wrong. And definitely there's more than just that negative sign means that you're not just shifting to the right one and down 5. Okay, so that's kind of cool. We actually, in this page, this is a nice page to take a screenshot because we actually talked about all the rules. So the next one should be pretty simple as if it's talking about transformations. Oh, look, it is transformations. So what do we notice? Well, we're going to use the vertex to tell us what happened. Vertex is just the lowest or highest point of the parabola. Normally, this function has a parent function, and you really should know what all of the parent functions look like. Okay, of all of our functions. This one in particular is the quadratic. We said the easy way to remember the quadratic is that the u in quadratic. And we can see that we shifted to the right 3. So what do we say when it's related to x? Do we follow the rule? When you play with your x, what do you learn from your x? Do you do the same thing or the opposite next time? Well, you learn that you do the opposite. So plus 3 means it's minus 3. And then with the back value, it should be exactly what it is. So then we notice that we also shift down. So we went to the right 3, and we went down 1. Remember, with x, it's the opposite. So we're looking for a minus 3. That's okay. And then, but with the y, it's exactly what it is. It's minus 1. It literally means, like, just to be clear here, when we say this, what we're really saying is y f of equals f of x minus 1. That's what this right here means. And f of x is the y value, and you're subtracting 1 from the y value. So you're shifting the y value down 1. Okay. Since we talked about parent functions, why don't I just run through them very fast? We did the quadratic. We also have linear. So that's easy because that's just the line. So that's what that one looks like. We also have the cubic, which looks like a snake. Okay. And then we have the square root function, which is y equals the square root of x. And this one, I guess I should write this one as y equals x cubed, and this is y equals x. And this one, I always think of this one as like the Nike sign. We also have the rational function, which looks like this. And that's y equals 1 over x. Now, is this in any way or form the only graphs that exist? Absolutely not, but these are the ones we discussed in class, so you should be familiar with them, with their shapes. Oh, and there's one more that we talked about, which is the absolute value. And that one's easy because there's a v, I always like to say absolute value, and the v is to remind you that this graph is shaped like a v. Okay. So, not the best artist in the world, but hopefully these little things help you to remember what they are. Okay, so you're seeing a lot of parabolas that we're dealing with. That is not to say that in the test you're going to just see parabolas. Okay, so keep that in mind. All right. So this is which of the following could be it. So I'm going to immediately eliminate B and C, and I hope you can see why. And the reason why that we eliminate B and C is that because this parabola is upside down. And when it's negative, when it's upside down, it means it's a reflection over the x-axis, which means it's negative. So it has to be either A or C. I can also see clearly that this function has been shifted to the left 4 and has gone up 5. So to the left 4 means we're going to have plus 4. So that means A has to go away and then up 5, which means C is the only answer choice that makes sense. I can't stress this enough. On something as high stakes as a final, you want to always make sure that you don't just choose the correct answer, but eliminate the wrong ones. Okay, there should only be one that sticks out. All right, so here's the next question. Which of the following is the correct value of this function? Again, I want to stress on the actual test. I know I keep seeing parabolas, but on the actual test, it may not be a parabola, maybe one of those other shapes. So negative means B is out of the question, and I hope you can tell me why. It's because that B is a reflection. The negative sign means it has to be reflected, and B is not reflecting over the x-axis. The plus 2 indicates that we follow, and this is the question, do I'm shifting to the right 2 or to the left 2? So hopefully you're saying to the left 2, which, see, this is minus 2 and this is 2. I know it's kind of hard to see here. That's minus 2, and that's plus 2. And it's always the opposite of your intuition. So again, what did you learn from your x? Next time you want the opposite. So if it's plus 2, you want to go minus 2. All right, so that's the answer. Okay, so which of the graphs below represents the base function square root of x? So now we're seeing different functions, and -3 over 2 square root of x. So we know that the negative sign means it's a reflection, which means, so the black one is the parent, so A is out of the question, and D is out of the question. And we know that because when it's negative, it means it's a reflection over the x-axis. Now the next question is, what happens to 3 over 2? Is the graph narrower or wider? And so remember, 3 over 2, because the numerator is bigger, this is an improper fraction, which means it's greater than 1, so 1.5. And what we said earlier with the parabola is that it's a vertical stretch. Vertical stretch is just a fancy way of saying it hugs the y-axis more. So notice that this one here is kind of hugging more than this one. This one's more narrow. It's hugging the x-axis more if you want it to see it the other way. So B is going to be the correct answer. If you panic, you can always just substitute in values too, by the way. So take something like the square root of 4 is 2. So if I say x is 4, this becomes 2. 4 multiplied by -3 over 2, which would leave me with -3. And you can see here that let's see, maybe I'm wrong. At 4, no, at 4 it crosses at -3. But this one crosses at -1. So B is the correct answer. So if you panic, universal tip, if you're taking a test and you panic and you don't remember the rules, you can always just plug in numbers and figure it out. Okay, as long as you know what square root means, you're okay. So hopefully that makes sense. Let's just keep it going. All right, compared to the graph of the base function, f of x equals square root x, you can also hear me say y equals the square root of x, but it's f of x, right? The graph of the function square root x minus 2 is translated. So notice that this is on the outside of the function. So this means this one goes, and you should know this from earlier. So, it's been a while, but we talked about the rules here. When it's on the outside, it shifts up and down. It's exactly like the intuition. So if it's exactly like your intuition, then when I look at this question, -2 means you're shifting down 2. It's as easy as that. Everything else is up, no, right, no, left, no. Okay, compared to the graph of the base function square root of x, now notice it's inside, so it's the opposite of your intuition. So it's -5 means +5. So this is the right 5. One last thing about this, and it doesn't matter what the function is. I'll use the square root since that's the one here. Just want to stress that these are basically the rules that we said. So if a, again, absolute value of a is greater than 1, it's a stretch, hugs y-axis more. If the absolute value of x is less than 1, then it's a shrink. This is called a proper fraction, and it hugs the x-axis more. Okay, so keep in mind that when it's less than 1, this is a proper fraction. But you also got to remember you can't get mixed up with fractions in general, because if it's an improper fraction, when the numerator is greater than the denominator, then like we saw with 3 over 2, then that would be a stretch, because 3 over 2 is 1.5, which is greater than 1. So if you do have any doubts, just type it in a calculator. If you get 0 point something, then it's a shrink, and if you get some number point something, like 1.2 or 3.4 or 5.7 or whatever, then it's a stretch. We also know h is the horizontal shift and this is counter your intuition. And all I mean by that, counter your intuition, is trying to make that look more like the word counter, is that if it says minus h, then you're moving it to the left. If it says plus h, sorry, I said that wrong. Minus h means you're going to the right, plus h would mean you're going to the left. I guess it would make more sense if I said it with numbers. So x minus 3 would mean you're shifting to the right, and x plus 3 means you're moving to the left. So it's the opposite of your intuition. And k is the vertical shift. And this is exactly like it says. So this is like your intuition. So what I mean by this, if you say if you have like a plus 2 in the back, then it shifts it up, minus 2 shifts it down. Okay, so that is it. Well, the last bit I should say is about a is if a is negative, reflection over x-axis. Okay, there are other transformations that exist. I am only focusing on the ones that I've discussed here on this page right here. So this is a great page to take a screenshot of and study for later. Let's see if I can get all of this in one page. Yeah. Okay, so you want to study this and make sure you're cool. The function is irrelevant. It could be square root, it could be absolute value, whatever. Okay, so now we've moved on to logs. This is a big part of where people had issues, so make sure you're paying attention. The goal here is to ask, can I write 243 as 3 to some power? So you could sit there and go 3 times 1, 3 times 2, 3 times 3 until you get it. You're going to get 3 to the 5th. The other way we talked about this is typing it into some graphing utility like Desmos and seeing if 3 works. But why am I using 3? Because the base here is 3. So because these match up, all a log is saying is, hey, if I can write 243 with a base of 3, what's the exponent? Well, you all know what the exponent is. It's 5. There's my answer. Pretty straightforward. Okay. Next up, if we see a question like this, remember it's all about getting the bases to match up. So I need 1 over 16 to match up with 64. So you're going to look for some number that they both can match up with. You could match them with 2 or 4. I'm going to use 4. So to me, this is obvious because I know 4 squared is 16. I know 4 cubed is 64. That might be a stretch for some of y'all if you don't know. If you know 4 squared is 16, then times it by another 4 and you'll get 64. If not, because they're both even, you can use 2 as well, and it would work with 2. It's just the numbers are uglier. So I'm going to rewrite 1 over 16 as 4 to the negative 2. And the negative comes from the fact that this 1 over 16 is 1 over 4 squared, but I want to pop it to the top. I don't want a fraction, so I'm going to write it as negative. Remember, negative means reciprocal. 64 is 4 cubed. And this is going to be raised to the 4x minus 3. Again, the rule is exponents. We multiply. So I'm going to distribute the 3 into both of these, and I'm going to get 4 to the negative 2 equals 4 to the 12x minus 9. The negative 2 and the 12x minus 9, they're going to match up. And then we're bound down to solving basic algebra equations, which I hope everyone at this point is comfortable with. So add 9 to both sides, 7 equals 12x. And then we're going to divide through by 12. Apparently I'm in love with these darker colors. 7 over 12 is x. 7 over 12 is my answer. Okay. If you super panic too, by the way, you can just plug in the answer choices into them. Without a calculator, that's pretty difficult, but with a calculator, it's not too bad. So that is an option as well. All right, more of the same. We see 625, see 5. I'm gonna take out if I didn't know. I know 625 is 5 to the 4th, but if I didn't know that, I would have taken out a calculator and just do 5 times 5, 5 times 5 times 5. 5 times 5 times 5 times 5, and I would say, oh, look, 5 to the 4th is 625, or you just pop it into Desmos. Okay. Also, this is a fraction. So because it is a fraction, I know that it's going to be negative. So this is log base 5, 5 to the negative 4. Once more, because the bases match up, when that's what a log is saying. When they match up, what's the exponent? The exponent's negative 4. There's your answer. Moving right along, we're going on to the next set of questions. So I alluded to this earlier. If you don't know these rules, logs are basically exponents. So we're related back to PEMDAS. So notice subtraction is the same thing as division. So because the logs are the same, we can say it's just log base 3, 4 over 2, which is log base 3. 4 divided by 2 is 2. You can see here that they're playing with, these two are the same. It's kind of funny. They're playing with the bases. So actually both of these match up, right? That's weird. Okay. That shouldn't be happening on the final. Okay. So any case, keep it going. Next one is more of the same. Now, I'm going to be honest with you. Something of this tier is not going to be on your final because you're going to have to use fancier math to do this. But even if this was on the final, you actually could still figure it out by playing with the answer choices. So that's how I'm going to play with this. So -6 and -2 are not going to work. And the reason why they're not going to work is that this x plus 1 is called the argument, and the argument of a log cannot be 0 or a negative number. Let me say that again. The argument of a log cannot be 0 or negative. So if you plug in -6, -6 plus 1 is a negative number. If you plug in -2 plus 1 is a negative number. So A and B are not valid. So I'll plug in 6. And so if we plug in 6, we get log base 7, 7 plus log base 7, 1. We're seeing if that's going to equal to 1. Well, I know log base 7 to the 7, if these two match up, remember this exponent is 1, this is just equal to 1. And remember we said log base 7 to the 1. Well, you can write anything as 1 as 7 to the 0. So if that's true, then again, when these match up, it's just the exponent, so that's 0. So this is 1 plus 0, which is 1. So the answer is 6. And that's it. So even if it's something that looks a little harder than what it's supposed to be, remember, you can always work it backwards with the answer choices. What they're asking you to actually do, addition means that you're going to multiply. So you get log 7x plus 1 times x minus 5 equals 1. And then what we would do is we would claw this. This would give me, 7 to the 1 equals x plus 1 times x minus 5. We factor it, get x squared minus 4x minus 5. By the way, I'm not doing anything fancy here. X times x is x squared. 1 times 5, negative 5 is negative 5. In the middle is just negative 5 plus 1, which is negative 4. And drop a line to keep things separated. Subtract 7. 0 equals x squared minus 4x minus 12. In general, if you are asked to solve any sort of like quadratic problem, any sort of trinomial, the goal is to get the trinomial to equal 0. And then you factor, and we get what? We want to get from 12. 12 is 4 and 3. Well, it's got to be minus 6 plus 2. And I kind of cheated here because I knew 6 was going to work, so I knew this had to be minus 6. And so x is equal to 6 and x equals negative 2. Notice they put negative 2 as an answer choice. That's wrong because if you plug it back in, it doesn't work. Right? So also illustrating the effects of using the answer choices. So we We didn't do a lot of this. I did put this as an extra assignment on Delta, but we didn't spend too much time on this, so don't stress if you were confused on the second half of it. You should be familiar with the clawing as a way of organizing, changing it to what's called exponent format. You should be okay with foiling, and actually you should be okay with factoring as well. So you should be able to do this, but we didn't do this specifically with logs, so not planning on putting it on the test. But it is a great problem to illustrate how to do it naturally, but also how to do it using the answer choices. Okay, moving right along. Here we have something. So one of the nice things to realize is that if you don't know how to start a log problem, you can always claw it. So we'll claw this. We'll get 10 to the negative 2 equals x. And we know that when it's negative, it goes to the denominator. It's that famous word, reciprocal. 10 squared is 10 times 10, which is 100. So x is 1 over 100. All right. Let's keep it going. So this is to try to scare us, but we know that when we add, we multiply. And we subtract, we divide. So this one's easy enough to say, hey, 4 goes into 36 9 times. I'm left with 9 times 9, which is 81. So this is log base 3, 81. Now what I love about this question is we know 81 can be written as 3 to a certain power. So you're either now typing this into Desmos, or you're just multiplying by 3s and seeing how many 3s gives me 81. It's going to be 3 to the 4th. And why do I want to write it like this? Because if these two match up, it's just the exponent. And the answer is 4. Cool beans. Okay. And you're seeing more of the same, right? So again, here, this is the same thing as 36 to the negative 1. Can I write 36 as 6 to some power? Absolutely. And what was the rule when you raise to another power? So you're seeing a reinforcement of the things we've talked about earlier, which is the goal, actually. And now that 6 and 6 match, we know that the answer has to be, if these match, it's just the exponent. There you go. All right, more of the same. How do I write 343? Well, you're either going to sit there and go 7 times 7 times 7 as much as you can, or you're just going to say, hey, 343 is 7 cubed, or you may just type it into Desmos, 7 to the x, and see which one gives you 343. It's going to be 3. 7 matches. It's just 3. I'm hoping that repetition is starting to kick in. You're realizing, hey, this is not bad at all. Now, this one's interesting because we're going to rewrite it as a log. So you could take your answer choices and claw them, or you can actually just claw that, the actual exponent form, and it tells you the order of how you write it. So 27, base 27, 3 equals 1/3. And you could literally claw that and see if you go back to the original, which you would. Now, I'm always careful here because it equals 1/3. So it's going to be that one. But be very careful when you're choosing your answer choices as well. A lot of the numbers are the same, so it makes it easy to make silly mistakes. All right, home stretch, guys. So this triangle is contorted, but we're looking for sine A. Remember, our trig, the only thing we talked about related to trig is SOHCAHTOA. And SOHCAHTOA is a fancy way of saying sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So opposite is the side across, which is 5. So this is opposite. So I know, and hypotenuse is the longest, which is going to be 13. It's also across from the 90. So we know that sine A has to be 5 over 13. That's correct. So B is wrong. C is correct. And D is wrong. We also talked in class about the reciprocal functions, and the reciprocal of sine is cosecant. So 5 over 13 and 13 over 5 has to work, which is C. Now, this is a famous triplet, which means that this is 12. We didn't talk about that, but even without discussing that, from what we did talk about, the only answer choice that makes sense is A. Very cool. All right, more of the same. It says which side is opposite. This is very similar to the last test. Here's J. Again, opposite is the one across, so that's LR. Okay. What is T and K? You take K. Remember, so ka toa tells me that K is opposite over adjacent. So this is O, this is A, so it's 10 over 5, which is 2. Okay. Sine A is 12 over 16. Notice the position, that's right here, so that's going to be 12 over 16. That looks fine. That's 16 over I don't know what. That's wrong. There's nothing there. That's wrong. There's nothing there. That's wrong. It's the first one. This is just, again, emphasizing what does O stand for. O is opposite in SOHCAHTOA. These are gimmies. And what is A? A is adjacent. Okay? So we've recently done this on the last test, so hopefully these questions are pretty clear. All right, guys, that is it. I know that I went fairly quickly, but that's because I didn't want to make this video too long. I hope this makes sense. I hope you guys are doing okay. Study this over and over and over again, and you'll be fine on the final. All right, guys, see you in the next math video, and good luck on your final. Happy studying.